at the beginning we use one counter to count the number of events, and then when run, for example, the sequence, it's possible to use another counter in order to discount what is the event to is not possible to happen in the future. Okay, if you are in the middle of the sequence. With that implication, it's possible to prune the speed of the search. Thus are the chain complexity for a priori, for PPA and maximum pattern. For example, in a priori and PPA, you can see of the both algorithms are related with the number of events. Okay, of course, minus if 1, 2, but it's more efficient. In the empirical result, we use two databases. The first database was a synthetic database with the purpose to check the algorithms were sounds. That means every algorithm find the sign patterns. Okay, that was the main idea. We vary the number of the period. If you see, we have the length of the sequence 500 and 750. A is the a priori, M is the maximum pattern, PPA, P means PPA, and F1 is minus F1. Okay? Usually every time when you increase, for example, the number of the period and the number of the length of the sequence, there is an increase of the time, considering support 25. When the support is increasing, for example, from 25 to 50, there is a reduce, okay, the time for every algorithm except to minus F1. In the second experiment, we use a sample of the geolife. It was very small. It's very small sample. That involved 3 persons in geolife. Okay, we are sure there is one pattern for every person. It was like a 5 megabytes. You can consider the geolife is about 200 or close to 300 megabytes. Same the previous, you can see, for example, every time when you increase the minimum support, the time for every algorithm decrease. That is reasonable, except for F1. That's very important to mention that F1 is not necessary to use a minimum support. Okay, that is very interesting, because every time when you increase or use support, you can discard some pattern. For example, if the type of the pattern are not so frequent, you can discard every time when you increase the minimum support. Indeed, if you use, for example, in another experiment, you can imagine that the minimum support is 0, is very probable to the time increase for every algorithm. Okay, in that case, minus F1 will have a better result in comparison with the other algorithms. From the empirical result, we can say every time when the length of the sequence is increased, of course the time for every algorithm is increasing too. Okay. The final result, for example, in terms of the seconds, millisecond specifically, it depends on the number of the period and the length of the sequence. Okay. PPI provides good results when the support is high. However, his performance is not stable. You can see that, for example, in the table 4. Okay. I forgot to mention that in that case, for example, there is not number in some rows because the execution time exceeds 3 hours. Okay. Maxwell pattern algorithms give a good result too. However, its performance is below to PPA. A priori, algorithm is the worst of all algorithms, of course, because he checks all possible subsets. However, every time when the support is increased, a priori reduce the time, of course. And finally, minus F1 present the best result well if you consider on the average. Okay, you consider of the average over the 4 tables. The best result is provided for minus F1. Well, in this paper, we propose a new algorithm called minus F1. Minus F1 is, we believe, is a very good algorithm because the performance is predictable and scalable. The time complexity for a priori, Maxwell pattern, and PPA were provided. That is very important to mention that time complexity have been not presented in the previous work. We carry out a lot of experiments with different support, different number of the period, and different length of the sequence. And we have a question for future research. What happens when the pattern searching is online? Okay, we believe that question is very important for the future work because we are present result for a static database, but when you are receiving data online, is the problem is different. Finally, thank you a lot. If you want any question, you can send me an email. Bye bye.